So I want to talk a little bit about what are the implications of the new developments in terms of AI for learning more broadly. As I said, in the first block of the talks, we have 3 different research presentations, and my presentation will be a little bit more conceptual, and the other 2 talks are very much empirical, if that's more of your thing. So we hope we have different types of talks for the different kinds of interests you all might have. But to say a little bit more about myself, my research area is in how people learn and develop skills in the workplace and how they use technology to support their learning and development, and how digital technology transforms not just the work practices and the organizational practices, but also how we learn and develop professionally in the workplace. And I have been active in this field for over 25 years, and I've researched, published and taught courses across a range of different topics and themes in this area, some of which are visualized here. More recently, as I say, I've become interested in learning and skill development in emergent forms of AI-based and AI-mediated work, such as online labor platforms, and then on the analysis of the implications of AI for human capabilities and skills more broadly. And I've published several papers on this topic. And I'm currently working on a book on the topic of AI and human capabilities. And the empty square there is, I don't want to jinx it by putting a name on it, but that's in the process. And the book project is funded through a grant from the Danish Carlsberg Foundation, and unfortunately not all of those 460 million went to me, and I was one of the 190 recipients from across Denmark. My work on this book will start in earnest in the summer, but today I'd like to share with you some initial ideas and observations based on my preparatory work for the book. So let me introduce you to Aidan and Aiko. They are interns working in a marketing agency, Codeword. They are not human interns. They are AI-powered bots. In the announcement, the company described how it expected that these AI interns will be full members of the company's 100 staff. Aiko will join the design team, and Aidan will work in the editorial team. Their tasks will include creating slides, editing photos, drafting concept sketches, designing icons, writing blog posts for the company's social media accounts, and also analyzing marketing trends and news. The performance of these AI interns will be regularly evaluated, as it is for all other employees in the company, and the company expects them to progress towards a full-time role in the future. The company has added Aidan and Aiko to their corporate directory, and they'll even receive a salary, which the company says will be donated to whatever cause, I can't remember. In this announcement, Codeword stated that Aidan and Aiko will be integrated into the agency's existing IT infrastructure, IT system, which already includes different kinds of AI-powered platforms. The difference is that these so-called AI interns will be focused more on the creative output, rather than the insights and analytics the company gets from the more traditional automated marketing technologies that they use. Although the company claims that these are the world's first AI interns, in fact, vendors' promotion of AI tools under the kind of the guise of digital employees is not at all new. It is well documented in the literature. But this example is interesting because it raises important questions. How is the introduction of such AI technologies reshaping the organizational processes and workflows? Importantly, what specific skills, mindset, capabilities do human workers require to work with such systems in the future? What would be required of Aiden's and ICO's human co-workers, managers, clients to work productively with these AI systems? Do we as a society accept that these essentially technological tools are anthropomorphized to such an extent? And what are the implications of such anthropomorphism for productivity, for well-being, and for human dignity in the workplace? And to many of these questions, we as educational institutions, as organizations, and as society don't yet have well thought through, clear and evidence-based answers. Aiden and ICO are just an example of a myriad of different types of AI technologies that are entering our workplaces and our daily lives in a myriad of different ways. Some more overtly and publicly, such as ChatGPT, and others in a much less visible and more covert fashion. But one thing is clear by now is that AI is not a single technology. In fact, it is, as some have called it, an archipelago of technologies, approaches, methods, each grounded in a different paradigm and targeting specific problem domains such as perception, planning, or communication. This map was devised by Francesco Correa back in 2019, and it's no doubt it's already outdated as new approaches and methods emerge all the time. But it is still useful to illustrate the idea of the multitude that is the AI. Now, my interest is on the so-called machine learning and deep learning subtype of AI. In this map, these are positioned within the kind of statistical paradigm of AI. The reason it is interesting is that it is foundational to one of the grand claims of the field of AI, and that is that a machine can learn and produce outputs that mimic human-level intelligence. You probably know Alan Turing, of Alan Turing, who is one of the founders of contemporary computing and AI. In his 1950 article titled Computing, Machinery and Intelligence, Alan Turing formulated this prediction here. And today, Turing's prediction has become reality, because today we speak of thinking, intelligent learning machines. This is commonplace, ingrained in our lexicon, and by and large goes unchallenged and unquestioned. A fundamental question arises regarding the nature of these machine learning algorithms. Are they merely engineering artifacts? Are they merely tools? Or are they agentic entities capable of learning? And of course, in the field of AI, there's the long-standing conception of humans as merely kind of computational architectures, and some even called humans meat machines. And these kind of perspectives seek to posit humans as merely a type of computational entity, but interestingly, imbuing algorithms and machines with human-like qualities. So a very interesting, curious inversion where technology is anthropomorphized, but humans are technomorphized or machinomorphized. But to answer this question, we need to be clear on what is agency and what is learning. And in my talk today, I want to address the question of or begin to address the question of how learning is understood, and to argue that machine learning is a misnomer, that machines do not learn. My second point is that AI does not have agency, but that's quite a big topic, and I don't have time to address that today. But I covered this and discussed this in detail in this paper, which is available online, should you be interested to read it. May I ask, how many in the audience are familiar with the notion of machine learning? Would you raise your hands? Quite a few. And how many of you have specialist knowledge of machine learning? Not that many. Okay, so the reason I'm asking is I would like to provide maybe a very brief kind of introduction of what machine learning is. So the term machine learning characterizes a category of algorithms that are designed to apply advanced statistical tests to massive large data sets in order to classify and cluster this data, compute correlations between this data, and predict patterns in this data, and then to enhance their own performance in a designated task, a task for which they were developed over time. Machine learning algorithms are said to be intelligent and learning because their underlying predictive statistical analytics is automated, which means that they can function without constant manual programming. And these definitions here are from some of the key AI textbooks, so they reflect the kind of computer science understanding of machine learning. So how does AI claim to learn? As I say, very brief introduction, very non-technical introduction. But currently, broadly speaking, there are 4 types of techniques of machine learning. These are supervised, unsupervised, reinforcement learning, and deep learning. There are various other subtypes, but this simple typology, I think, will do for our discussion today. Forgive me, specialists, if this is an oversimplification. So in supervised learning, the machine is essentially presented, or the algorithm is presented with a massive data set of examples of a particular notion, pairs of input and output. For example, a photo of a blue bus that is paired with a label bus. And then the algorithm learns to predict the output, so the appropriate label, from similar, if not identical, future input. For example, when it sees a photo of a red bus, it knows that it's a bus, even though it's not a blue bus. So the data sets that are used for supervised learning are typically labeled by humans. And supervised machine learning can be said to be superficially similar to native language acquisition among humans, where children learn language because adults sort of point and name objects repeatedly until the child learns to associate the concept with the object. Again, this is a very kind of rough analogy. Unsupervised learning involves the machine linking inputs to outputs, but without explicit labeling by humans, so it's not supervised. Instead, the algorithm itself infers patterns among a large number of input examples through a statistical technique called clustering. Reinforcement learning does not involve any data labeling, but it includes periodic human feedback to reward desired action or to punish failure to execute the desired action. An example of this is a chess playing algorithm that receives feedback on whether it has won or lost, and the algorithm is then programmed to use this feedback to identify which of its actions prior to reinforcement are to be attributed to the feedback received. So it is programmed to change its future actions to achieve the outcome for which it is rewarded. So this form of machine learning seems to have taken its inspiration from the early 20th century stimulus response experiments in animals, the famous or infamous Pavlov's dogs and Thorndike's cats. And finally, deep learning is a machine learning technique through which the algorithm is programmed to draw on so-called artificial neural networks. It's essentially a multi-layered network of mathematical entities that are kind of pseudo-analogous to how biological neurons work in human brain. And the depth in the deep learning refers to the use of multiple layers of such mathematical entities and networks, which enable the computer to perform kind of its learning in a faster way. But unlike, an example of this technique is seen in ChatGPT, where the algorithm draws on a large language model, which is exposed to large amounts of text, and then it can generate new and coherent combinations of new text by calculating regularities and patterns in which words and sentences appear in this large text corpora on which it is trained. And unlike the other types of machine learning, a feature of deep learning algorithms is that they are programmed to create new algorithms themselves by recognizing rules governing patterns in the big data and generating new rules accordingly. Now, these brief descriptions are not technical, and I do not claim to have the specialist technical knowledge to understand and communicate the intricacies of these computational approaches. But the technical details for our discussion today are not essential. What is important is the big picture. And I think the big picture that emerges from this discussion is that in reality, what AI algorithms do when they are said to be learning is essentially processing data, processing information, and using predictive probabilistic statistics. So this has led to some to call machine learning is nothing but sort of statistics on scale, statistics on data, steroids. And it is essentially a limited and a narrow conception of learning as information processing that the notion of machine learning is built on. It is the erroneous idea that if an entity, in this case a machine, is capable of processing information, then this entity is capable of learning. But this kind of idea, erroneous, false idea, aligns well with the foundational myth of AI, in which humans are viewed as mere information processing entities. So the core of the AI practices, then we can say essentially consist in data classification, data extraction, data labeling, and ordering of the data. However, these processes bear very little resemblance to genuine human learning, which is constituted of processes altogether different from the kind of statistical calculative logic of the AI algorithms. Now, a short talk like this one is not a suitable format to begin to discuss the definitions, conceptualizations, and theories of learning, which if we were to do, we would be here a very long time indeed. But the quote here isn't really also a definition of learning, but I think it encapsulates well how beyond mere information processing and pattern recognition, learning is understood first and foremost as a profound structural shift in the premises of our thought, of our knowledge, of our perspective, and of our action. So, in support of my proposition that machines do not learn, I'd like to briefly outline some foundational concepts, mechanisms, and processes that are central to human learning. These are not meant as a full description of how humans learn. This is a very complex topic for this talk. But I just want to highlight a few kind of fundamental things that are important. The first kind of notion is purpose and intentionality. So when we learn, we don't merely respond to pre-programmed instructions. We choose, we determine, we act with intent, we apply our will to achieve a particular goal we set ourselves. And this contrasts with the kind of unconscious reaction to stimuli from the environment, from reflexes, instincts, and other non-voluntary responses to the environment. And central to the purpose and intentionality as foundations of learning is our unique human capability to transcend the diktats of our environment and to shape our own life circumstances and our life courses and our own learning. AI and machine learning lacks this kind of intentionality, it lacks this kind of purpose. It is this extension of human intentionality and purpose, and rightly so. The second idea or concept that is central to learning is this idea of frames of reference. And frames of reference are understood as sets of assumptions, expectations, mindsets, habits of mind, and perspectives through which we construe meaning and attribute coherence to our experiences. Human learning essentially consists in transforming these frames of reference to make them more accurate, more inclusive, more nuanced, more complex, open and reflective. And this kind of transformation occurs through critical self-reflection, through unlearning, through relearning, as well as learning. So merely processing and regurgitating information without the corresponding sustained transformation in our frames of reference does not constitute learning. And so ChatGPT can process and regurgitate and recombine text in ways that sound very credibly human-like, yet it cannot engage in this sort of transformation of self that is an essential attribute of learning. Cognitive dissonance is also a very important stimulus, an incentive for learning. It is defined as this uncomfortable internal state that occurs when we are encounter new information that conflicts our commonly held beliefs. Cognitive dissonance triggers usually learning processes by stimulating us to engage in problem solving, the construction of new knowledge structures and frames of reference, and change our behavior to alleviate the discomfort that is caused by this dissonance. So AI is incapable of handling this sort of cognitive dissonance, let alone use it for transformation and for learning. And self-reflection is an absolutely essential learning capability in humans, and without self-reflection, no genuine learning can occur. So it is true that both humans and machines can improve their performance based on experience, repeating a certain experience or action several times and learning from feedback on that action or from rewards and punishments. But the ongoing critical self-reflection and self-reactiveness are absolutely essential for us to effectively integrate this kind of feedback into our behavior. And this kind of self-reflection absolutely requires self-awareness, and that is something that machines, as currently conceptualized, do not have, because the self-awareness is essential so that we can examine our own functioning, evaluate the soundness of our own thoughts, and discern the meaning of our own pursuits. Finally, social learning is a key mechanism of learning in humans. We learn from others through many different processes, through observation, through imitation, through dialogue, sharing knowledge, cooperatively working on problems together. And machine learning algorithms currently do not have the capability for social learning because they primarily draw on their own self-referential experiences. So, to sum up, while human learning processes leverage purpose, function, intentionality, goal setting, transformation, self-reflection, social learning, machines are unable currently to undertake these essential defining mechanisms of learning. Now, why does this all matter, you could ask me? You could say, well, it's just a metaphor, it's just terminology. Why does this matter? Why should we worry about this? I claim that the use of learning, the term learning in relation to machines, presents several inherent problems for us as individuals, but as a society. First of all, it promotes simply an inaccurate and misleading depiction of what AI can and cannot do, whether it is wielded sincerely as a technical metaphor used with intent to obfuscate or stems from intellectual complacency. And so arguably if the creators and advocates of machine learning were to embrace more precise but less sensationalist terminology, their innovations might struggle to captivate the public imagination, maybe to secure substantial funding, because advanced predictive analytics sounds much less exciting and much more boring than claiming that your creations can learn just like humans do. Importantly, this increasingly powerful discourse around technologies and capabilities of technology that is spearheaded by AI developers and kind of the tech sector exerts a profound influence on our society. It shapes minds, hearts, perceptions, practices, and it also generates anxieties. The use of uniquely human terms to describe machines has a significant impact on our collective psyche, and it has the potential to fundamentally alter our self-perception and our self-understanding of our place and our role within our increasingly AI-mediated society. So I'll stop there, and I hope that this talk may have helped to contextualize some of the claims regarding the capabilities of learning machines vis-a-vis human capabilities, and so that we can begin to bring about the much needed kind of disenchantment with the AI. So thank you. I think we have some time for questions, 15 minutes? 15 minutes for questions. Thank you. We also have participants online, and if our online participants have questions, please feel free to ask, and we will raise your questions in the audience here as well. Yes, please.
Thank you very much.
Sorry. I
Yeah,
have a microphone.
we have a microphone, so please raise your hand.
Yes, and it doesn't work. It works. Yes, great. Thanks a lot. Very interesting talk. My name is Christian Hendriksen here from CBS as well. And I'll add an additional perspective because I think this is very valuable for the discussion. I realized that some of the things we take for granted for everyday things like understanding and reasoning has stopped making sense to some extent. So when we only had humans that could produce human-like text, it was fine when Mark would send me something that I think, okay, he understands what I'm saying because I could see it in his text and his speech, and I know that he can reason because he's a human. And then when GPT-4 came around, I think probably everyone who used GPT-4 for more than 10 hours get this, that it no longer is clear whether a machine understands or not, because it can produce text that's better than what I could make. And because I think I can understand and reason on things, I'm not sure how to think about the concepts of understanding and reasoning, when a deep learning network can produce things that's better than what I can do. And I know that I would probably expect that in 2 years' time, it can probably produce things that are way more creative and better than most of the things I would be able to do. So I'm curious on your thoughts on these fundamental concepts, reasoning, understanding, thinking, that we all kind of could take for granted because back in the day we were only humans that could make this kind of text. And now suddenly we have machines that can do the same. What are your thoughts on this?
Yes, thank you. You mentioned a few times the word better. What does better mean? Faster? For sure, faster than it does all those things faster than we could do. But does it truly, for example, ChatGPT, does it truly understand what it does? There are a lot of examples posted daily on Twitter and LinkedIn about, a very basic thing that a human would understand, that ChatGPT delivers a very, very kind of complex, well-worded response, but it doesn't understand the basic kind of the concept underpinning it. So it is true that our kind of fundamental notions of understanding, agency and all those things are actually challenged, but I would argue that they are superficially challenged. But once we start looking at into the kind of the depths of what actually happens when these algorithms and machines, what do they actually do, that we understand that maybe these notions are not as challenged as we think they are. And I think moving forward, this AI obviously is a very, very helpful tool to improve speed, to improve accuracy, to improve productivity, to give us, ideas and support in making decisions. But I would argue that at least based on how these machines are now, today, they are not necessarily exhibiting understanding or exhibiting all these other kind of human qualities that you mentioned. So we may disagree on that. Yeah, but please.
As well. Thank you for your presentation and the very nice and provocative thoughts about this matter. I was wondering if you could give us a reflection about the way that humans are biased and use heuristics in their cognitive processes and also in their learning. Could this be an advantage that we may have machines that can expose, but in a positive way, going into your conclusions, the way that we are biased, and we may reflect over how to be less biased? I'm not using the word heuristic because heuristics in research is seen as a positive thing that humans use in order to make decisions. But when it comes down to bias, and here we could have a discussion about trash in, trash out in terms of data that we feed the machines. But still, can we use this in order to reduce, whenever possible, bias in decision making for humans? Because that would be definitely something positive for human learning. Thank
Yes,
you.
I agree to some extent, but also I think it links, your question is somewhat linked to the previous question, and my answer is probably going to be, my sense, at least in how I think about it at the moment, is going to be that yes, the machines can help rectify bias in certain areas, but also they introduce their own kinds of biases that we know. There have been many well advertised examples of kind of gender bias, racial bias, and all kinds of other unsavory biases in large language models, generative AI, and so on. So I think relying entirely on technologies, and that's not, of course, the point you make, and that might be a caricature of what you actually said, but relying on machines to kind of outsourcing the heuristics to machines, it would probably be the wrong way forward, and I think the more reasonable way forward would be to kind of question, transform our own kind of thinking about our own biases through transformational learning and some of the other mechanisms that I have outlined, and then use machines to support us, but also be critical of the outputs and the ways in which machine kind of generates these outputs. Mm-hmm. Mm-hmm. Sina here.
Hi, my name is Sina Sambak, and I'm from Department of Digitalization here at CBS, but I also have a background in computer science and data science, and we have been using the term machine learning for like 30, 40 years, and neural networks even longer, which is also a misnomer in a sense, right? But what should we say instead of this then? Because we need a concept for this data-driven analysis where we use nonlinear relationships to be able to predict and infer more things that we used to. What should we call this if not machine learning? So do you have an alternative term or something? Because I'm,
Yes.
It is just, for us, it's just a term. I'm not thinking that the machine is learning. It's just a word for me. But I understand that it can be a problem.
I think maybe this kind of the misnomering is more of a problem not within kind of computer science proper and people who kind of teach it on a daily basis, people like yourself who do research on this and teach it, but more in terms of how the technology sector, the Silicon Valley and the kind of the powerful tech uses this term as a kind of way to influence how we think about their creations, as a society, as policymakers, as educational institutions. So that, I think the kind of the danger is really there. And what are the alternative terms you could use? I think it's very unlikely that the sector will stop using the term machine learning, and if it is a useful shortcut, that's fine. But I would encourage and argue, and I would think that a suitable thing to do would be to always come up with this disclaimer explaining that this is a metaphor, this is not meant, as learning, and this is oversimplification of learning. So to be clear with the public, with the students, with the learners, with clients, that what this technology actually is. And I think the technology sector and computer science is in a way owe this kind of disclaimer to the public. And of course we as a public should also improve our own understanding of the kind of the basic principles underpinning this technology. And I think we will do that more the more this becomes central to our everyday lives. Do we have time for one more question? I think Jakob there had a question.
Just to follow up, I'm Jakob Nabia. I'm also from the Department of Digitalization. I also have a background in computer science, although not in AI. But I was very active, or at least followed the discussion back in the 70s and 80s about what went on there, and what Weizenbaum, Dreyfus, and all these guys. You have also read them. The thing that struck Weizenbaum was our tendency to trust the machine when he made his very, very simple chatbot. So people were ready to engage with that machine, right? And they sort of took the answer seriously, and they didn't even think about that someone else, namely Weizenbaum, would follow the conversation because it was a research project. But we see it today now again. It's a machine, it must be right. And it's true that these machines are not biased because they just take the input and produces an output. But a human decided the input. And the human, or sometimes a lack of a human, does not check the output. These decision models, they never get the feedback on what actually happened. When you deny or you don't accept an application to a college because this person is, according to the machine, not suited for higher education, you don't know what happened to that person afterwards. So if there's a bias in the machine, it stays in the machine. But we trust it.
Mm-hmm. Yes, so this, this is, you mentioned Weizenbaum and the ELISA, experiences. And of course, these, the perils and dangers of humanizing technology in this way are also well critiqued also in social sciences literature, where, humanizing technology in this way and overly identifying with technology in this way can introduce a whole lot of problems, not kind of more conceptual, philosophical problems, but also there are many examples of kind of pragmatic problems where, for example, a person engages with a scheduling chatbot and the chatbot keeps changing the appointments without the explanation, and the person gets annoyed, and so so I would say yes, that there are so the kind of the anthropomorphizing and humanizing technology is a problematic issue and has been for many years. I want to say also that some people have called, and I'm not saying that I agree with this or necessarily disagree with this, but I would like to throw this into put it on the table for us today, is that now some people have called on kind of regulators to kind of prohibit the use of kind of humanizing terms in relation to machines, especially when marketing these machines. And now, I don't know where this, where this cause would succeed, but certainly there are voices around kind of highlighting some of these kind of issues that you have highlighted and coming up with kind of policy-based ways of dealing with it.